In this video, we will be discussing about something called super mesh here. So this will be your super mesh, and basically this is a part of mesh analysis, and there is a concept where we need to use something called super mesh. So let us see what is that. So what is a super mesh? So super mesh is applied when we have to use this concept. It is applied when when there is a current source, when there is a current source common to two mesh, in this case we have to apply the super mesh concept. So here in this figure you can see here, so this is one current source which is common to this mesh and this mesh. Right now I have not written any mesh loop, but this I can see this current is shared with two nodes, two meshes. In this case we have to apply the super mesh theorem. So now we know that it is applied whenever there is a common current source that is divided into two branches, or it is shared by the two mesh. Okay. So now to solve this, so let us do, we will take the mesh first here. So to solve this, we will be taking three mesh here. So let us take this one as mesh 1. Okay. So because of mesh 1, the current flowing here is I1. Let us take this as the mesh 2, and the current flowing is I2, and this will be your mesh 3 when the current flowing is I3. So taking the mesh is not a problem, it is the same process that we have followed before. Okay. So now we will write the mesh equations. So if I write the mesh equation, so for mesh 1, so for mesh 1, what we can write the equation? So see here, 50 volt is there, then 10 ohm is there, and 5 ohm is there. So if I write, I can write 50 minus, okay, so 10, so 10 whole into what? I will write I1 minus I2. So because I1 is flowing in this direction, I2 will be flowing in this direction, again minus 5 whole into I1 minus I3 is equals to 0. So this is my one equation. Next is, what is super mesh? So if I consider mesh 2 or if I consider mesh 3, then I can see here, so one current source is there which is divided or which is used by two of the nodes. In this case I cannot directly write the mesh equation, so we have to apply the super node technique. So what is that super node technique? So we have to combine this mesh 2 and mesh 3. So for super node technique, we have to apply here super node technique. Now what is that, or why it has to be added? Because this 2 ampere current source is common to mesh 2 and mesh 3. That is why we have to apply the super node concept. Now what is the super node concept and how does it apply? So while writing the equation for the super node concept, we will consider that mesh 2 and mesh 3 are combined and this is a big mesh. So let us write that equation, then you will get better understanding. So what I am saying, so we have to write mesh 2 plus mesh 3. We have to add both the things at the same time. We are combining these two nodes, two meshes. So what will be the equation now? So here it will be, so from here I am starting. Now 10 whole into what? I2 minus I1. Okay, then plus, you can see here 2 ohm is there, so plus 2 whole into I2 again. Now we will not write this 3 ohm right now, so we have to take this full. So I will write plus, here current flowing is I3, 1 into I3, so I am writing I3, then plus 5 is there, so 5 whole into I3 minus I1 is equals to 0. Now, this will be my mesh equation for the super mesh. So, if I solve this, then what I can get? So, if I do the addition subtraction, then I will get here minus 15 I1 plus 12 I2 plus 6 I3 is equals to 0. Okay. Now, this is for super mesh we have written. Again, you can see here what is the value of this 2 ampere. So, if I consider this node, then this is flowing in this direction. So, this 2 ampere current. So, for 2 ampere source we can write. So, I1, okay, sorry, I2 minus I3. So, I2 minus I3. So, I2 is flowing here, okay, and I3 is flowing in this direction. Sorry, I2 is flowing in this direction, I3 is flowing in this direction. So, I2 minus I3 value will be how much? It will be 2 here. Okay. So, if I use this equation, that implies your I2 equals to 2 plus I3. So, this one I can use where? I can use in the equation number 1. So, if I use in equation number 1, then what it, sorry, yeah. So, equation number 1. So, if I use this I2 minus I3 is equals to 2. So, here I1 minus I3 is there, I1 minus I2 is there. So, if I replace all the values, then what I can write? So, here it can be solved also. First, let me write the solved one. So, it will be 15 I1 minus 10 I2 minus 5 I3 is equals to 50. You can write like this. So, if I put this one, I will put in equation 1. So, now this becomes my equation 1 after solving. So, what new equation I will get? I1 minus 15 I2 is equals to 40. So, what I have done, just replace the value of I2. So, I3 is, now I3 is eliminated from this equation. So, let me take this as equation number 3 and this is equation number 2 for the super mesh. Okay. And the same thing we can apply in equation number 2 also. This can also be applied here. So, if we apply that, then we will get minus 15 I1 plus 18 I2 is equals to 12. Okay. So, what I am doing? I am putting this value of I3 here. So, I am eliminating the value of I3. So, then what we will get? We will get this as, let us say, equation number 4. Now, what we can do? We can solve this equation 3 and 4. So, there are two variables, two equations. So, if we solve this in calculator, directly you can use the calculator to solve this. No need to go for variable separation method and all. So, I will get here I1 value is equals to 19.99. So, while solving you should calculate this all and then you write the answer. Do not just copy the answer, because I have already calculated this value. So, I am not calculating right now. Okay. And here the I2 value will be how much? 17.33 ampere and your I3 value will be equals to 15.33 ampere. Okay. Now, what is the question it is asking? So, in the question, to find out what is the current value in the 5 ohm resistance. What is the 5 ohm resistance? 5 ohm resistance is here. What is the current in 5 ohm resistance? So, current in 5 ohm resistance is equals to I3 minus I1 you can take, or it is I1 minus I3. So, whatever you want you can take and you will get the same answer. So, current in the 5 ohm resistance is equals to I1 minus I3 and that is equals to I1 value is 19.99 minus I3 is 15.33. So, that will be equals to 4.66 amperes. Okay. So, this is the value in the 5 ohm resistance. So, this is how you can use a super mesh concept.